All right. There we go. Okay. Over which intervals is h continuous? Is it continuous from -3 to 3? No, because it's discontinuous at 2. Is it continuous from 3 to 5? Yes, it sure is. So it's continuous there. This one, where is it continuous? From 2 to 7? Yes, it's continuous from 2 to 7. How about from -4 to 0? Yep, it's continuous. Both of those. Which of these is continuous at -2? Can you take the cube root of -1? Yes, you sure can. You can take a cube root of -1. Can you take the fourth root of -1? No. Nope. So it's continuous at h only. Because this graph would stop at -1. So at -1 would stop, and here's -2 over here. All right. All real numbers. Does this have a domain of all real numbers, the natural log of x? Well, you want to look at the graph. And once you look at the graph, you'll see that you can't take the natural log of a negative number, can you? The graph looks something like this. So this one is, no, it's not continuous for all real numbers. How about 1 over x? We're looking at 1 over x. Oops. The graph looks like this and this. Is it continuous over all real numbers? No, neither one would be continuous over all real numbers. Okay? And we said the natural log is not. How about 2 to the x? Can you take 2 to the -4th power? Yeah, 2 to the negative power works. Can you take 2 to the 0 power? Yeah, 2 to the 0 is 1. Can you take 2 to the 5th power? Yeah. So this one works for all real numbers. Okay, finding the value of k. What would make this continuous here? Okay, because when we put in a 3 here, 3 plus 13 is 16. The square root of 16 is 4. 4 minus 4 is 0. So you get 0 over 0, which makes a hole in the graph. Okay, so what would k have to be to get rid of that hole? Well, if I was a thinking man, I would graph this out. Okay, what does a number like, that makes it kind of hard, but it's easier on a graphing calculator. So let's look and see if we can find a hole on it on the graphing calculator. So turn it on, y equals, clear out this, parentheses, x minus 3, parentheses, divided by parentheses, the square root of x plus 13, get out of the square root, minus 4, graph it, boom. So it looks like that. And let's go, well, there's no hole in the graph. Well, if you look and you trace, 0 doesn't have a hole, 1 doesn't have a hole, 2 doesn't have a hole, but 3 has a hole. See how that's empty there. So what I would do is I'd go, well, what's 2.99999? If you trace to 2.99999, it's 7.99999. So what would k probably be? 8. That's how limits help you out when we're talking about continuity. 8 would be the value of k. What would be the value of k here? Again, graph it. So y equals x plus 1, x plus 5 minus 2. All right, so if we look at this, we're looking at -1. So if we trace, because like -2 has a number, -1 is empty. So if we go -1.01, looks like the value of k should be 4 to make it continuous. Okay. This one, again, 0 over 0. What I would do on this one is I would just factor it quick. X minus 4, x plus 3 over x minus 4. These cancel. If you put a 4 in here, it would equal, 7. So basically the piecewise function g of 4 would equal 7 if it's continuous. Okay, so you have to, piecewise function 7 if g equals 4, and if it's not, x is equal to 4. If x is not equal to 4, then this goes here. Okay, so that's the basics of what you're doing in this. So quiz, and then we'll do another couple sections on Friday. Yep.